Now the last subtitle here is mutual inductance. In time domain we examined this, so we're going to examine it once more. Definition relation in time domain is this, if you remember, and we know in frequency domain derivative is going to be replaced with j omega. So if you do the replacement, this definition relation in time domain becomes this in frequency domain. Even you go further in the definition relation of time domain, for the ideal transformer, that means the special case of this, most of the time this formula use ideal transformers are used. So definition relation is this. So you're going to replace, this is like a resistor type of relation. So you can replace all the quantities here with their phasors. So the definition relation in terms of phasors becomes this in frequency domain, while n is equal to the number of surroundings in these inductors, ratio between these surroundings between those two inductors. So there is one application where the common application of this is impedance matching. So you can, if you say that you've got a ZL here and ZS here, and if your ZL is not the complex conjugate of ZL, then you're going to say that I cannot transfer the maximum power to the load. Therefore, there's going to be loss. If you put a transformer, ideal transformer like that in between, then you could do this transformation. Then maximum power is transferred to this. So this is the most common usage of the transformer in electronics. So you could do this calculation your own at home. And on the right hand side here, there are, so this is a transformer, and there is a load here, and before that circuit, that means you can say this one, there is a Thevenin equivalent of the previous stage. So what would be the relation between, for example, how are you going to explain Z11 is the impedance seen from here, Z22 the impedance seen from here, both these are the equivalent. So input impedance ZAB, so these are some formulas that we use in practice. How we do calculation is explained here, not commonly used once. You could see the similar calculations in the book, reference book that I gave you at the beginning.